worksheet. And 3 of them will be worked out on videotape and posted to YouTube, God willing, and the creek don't rise. Would you like to hear an interesting historical note on that? All my life, I grew up in Vicksburg, Mississippi, next to the Mississippi River, and all my life I believed God willing and the creek don't rise meant God willing and the water doesn't rise up and cause a flood, right? That's just how I interpret it. And the AP US history teacher who was here before the ones that are here now said one time, do you know what that means? And I told her what I thought it always meant. And she said, no. She said, God willing and the creek don't rise means the Creek Indians. Isn't that interesting? God willing and the creek don't rise, an Indian uprising, yeah? So I thought that was kind of interesting. There's a little bit of cross-curricular education for today. Okay, so there are a couple things I want to hit first. Just little pearls of wisdom all the time. Let's see. No. None of that. I don't know where this stuff goes. Okay. Oh my goodness, if there were ever a period that I wanted to show the Little Mermaid, it is this period today.
We should do that.
I just want you to know I can't do that. But I like to tell you that I want to. So you know I'm human. Okay. I want to make sure that you know that, tell me how we know that 5 kilograms has a certain force associated with it, and we know how much force that is. How do we know that?
Because of our tendons for the
What's our model?
weight equal to
Our weight, right? Mass model, which is that FG equals what? Newtons per kilogram, okay, times mass. And what I want you to know is that that's the first way you're learning it, and you may have seen this before, but I'm just going to say it, the FG. Another way to say this is just by using the term G. You have to know that I've heard some people saying, like, if I have a box here, we're talking about the free body diagram, and the force normal is here, and I've heard some people say, and I'm putting this in quote, and gravity is down. That is danger, Will Robinson, yeah? Anybody know what that's from? Boston Space. Okay, so it's really dangerous for you to say gravity down. What you have to say is what? The force of gravity down, because gravity is this. The force of gravity is Gm, or mostly, if you're going to write it just with variables, mg. Do you understand what I'm saying?
Yes.
Okay, so I just want you to know you have to be careful with that language. On the problem that I scored at the AP exam, people lost points for all kinds of comments where they used G, various G's. We have a couple of other G's as we move through the year, but they used those as synonymous for force, which they aren't, right? The force is the mass times the acceleration due to the Earth's gravitational field. Okay? Got it? All right, I want to also review that we found that A and M are inverses of each other, yeah? And that the slope we found to be, in that case, was the fan force, right? So MA equals F fan, but that the general equation for this is the F net, right, the sum of all forces equals MA. We can say the sum of all forces equals MA. So in this case, it was just the fan force, but we would take all the forces acting equals mass times acceleration. If you look on your equation sheet, though, you'll see that your equation sheet, everybody looks on their blue equation sheet as she says it. I hope I hope your other classes have just dialed it down, so you're just taking naps in there. Is that what's happening?
I wish.
I like that. Little Mermaid? Yeah, Little Mermaid, okay. All right, so what's true is that what causes an acceleration is when you look at all the forces that act on a mass, right? If we apply a force on a mass, then we get an acceleration. This should be reminiscent to you of 10 newtons per kilogram, right? Gives us G. So on your equation sheet on the AP exam, it says, hey, if you look at all the forces on a mass, that will show you its acceleration, right? We apply a force on a mass. I already threw the bad pen because I was doing impulse momentum theory in AP Physics C. But if I apply a force on a mass, yeah, then I get a what? I get a what? An acceleration. Right, just like that. Nice job. Okay, so those are things to know. All right. So 1, 2, 3. Okay, so I feel like I started 5. Do you have 6? 5 or 6?
You said 5 for us.
You have 5 or 6 though. Do you have 6 of them?
You said you did 5.
7?
Yeah.
Okay, so 1 through 5 for tomorrow. All right, so I started working out 5, and I just got a little way on 5, so I don't know, you want to do 5?
Sure.
Okay. All right, so probably somebody wants to start the video. Really? Gee whiz. Okay. All right. Sorry about that. Okay. All right. So let's just start 5. I'm gonna start by saying that we have some equations that we have found recently. They're on the board. What are they? That involve let me tell you the unit we're on. It's the constant acceleration model, unbalanced force model. Okay, so that's what we're on. So we've found 2 equations doing our fan car stuff, yeah? Or maybe our rolling the battery down the thing. It doesn't matter. It's all the same, yeah? Okay, so what equations did we find? It's going to be a long day if we do it this way.
V equals AT plus
Bingo,
V
nice
naught.
job, nice job. V equals, and on your equation sheet, it is V naught plus AT, yes? Say yes.
Yes.
Super great. Okay, now, there's another one. Can someone else say that one that we found? Someone else.
X naught plus V
X
naught.
equals X naught plus V naught T plus 1/2 AT squared. Yep, is that fine?
Yes.
Do you understand that each one of these terms is displacement? We talk about that? Meters, 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 yeah? Okay, so it turns out that these 2 equations can be combined to derive an equation. I'm just gonna put it right here. And it is, I'm not gonna make you do it, although I know that makes you sad. V squared equals V naught squared plus 2A X minus X naught. So really 2A times the change in X. Hold on to your poncho. All right, so this equation is particularly useful when time is not given. Do you see that there's no time in this equation? So that means you can And sometimes the equation is just written 2a delta x, right? And if x naught is 0, then it's just x. All right. So that's great. The other equation that we just talked about that we have is A equals F net over M, right? So that's our other one. Does it feels like, it just feels like it's just a little blurry. Is that my imagination? Maybe? Is it blurry? Not really? It's just terrible? Okay. All right. So far so good? All right, so I'd like you to add this on your paper. I'd like you to add FBD 0 to 8 seconds. And then I'd like us to make another one. Just whatever, okay? And this one is FBD 8 to 13 seconds. Okay? All right, a well-labeled diagram of the situation is a sketch, okay? So I'm gonna make a sketch that is, hold on, I'm sad for my sketch because it's running into the, hold on, it's running into my graphy thing. Thank goodness I have lots of whiteout tape. All right, so, what do I think? I really need a color. Is there anybody who has a color? I need an extra color.
It's a red.
I've got purple and pink and orange, and I really don't like red. Oh, but it can't be a highlighter. Green is good. Throw it. Oh, nice. Okay. All right. Stay ready though. Okay, so here's what I want to say. I'm going to start it over here, and I'm going to say the dog is and right here it's going, this is my sketch. Hold on. Yeah? And that is constant velocity model, right? Say yes.
Yes.
Okay, so that's true. And then I could say next what? Yeah, and then I could go all the way over here, yeah. And so this would be, the acceleration is that way, and it's the constant acceleration model. Yep. And what do I know about constant velocity model? Yeah? And what do I know about the constant acceleration model?
What's our noun?
And what is my order of operations all the time on problems that I'm working? I want to first do a what? Free body diagram. Second, I want to make equality statements. And oh, sorry people on the video. Okay, there we go. And third, I want to use my math models. All right, that's the plan, Stan. All right, so I'm going to back out a little bit. So I've got a little sketch, right? Make a well-labeled diagram. Okay, so that's A. Make a force diagram, right? So we want to do a force diagram for the dog at these two different times. So let's do it. Ready? So what do we got? Once you've spoken, then let somebody else speak. What do we got first? Somebody say it. Okay, all right, force of gravity, so I'll say F, G, what? On dog by earth. Okay, what else? Okay, let somebody else speak. Force normal on dog by ground. Okay, somebody new. What else?
Force push.
Yeah, what if we say force push on dog by ground traction? How about that? All right, so think dog
Can you
would,
move it down?
yes, think the dog would like slip out, right? If there were no traction. Does that make sense? Okay, so then we're gonna go back to what might be slowing it down. So let's say the dog is not rubbing its feet against the ground, that kind of friction, not that, but what could be acting against the dog as it trotted along? Sure, air is a thing. All right, so we're saying this piece is just for 0 to 8, so force air on dog by air. That's a little redundant, yeah. Okay, so far so good? All right, so this is, in green is the balance force, right? Constant velocity. So let's do from 8 to 13. What's happening from 8 to 13?
The force normal and force gravity are the same.
Okay, all right, so I'm gonna say, and is there any reason for them to be different than they were up here? Okay, so force gravity is on the dog by the earth. What else? Force normal on the dog by the ground. Okay, now what's happening that makes this piece different? It's accelerating, so balanced or unbalanced? Unbalanced. Do you think the air resistance is likely to change significantly? No, so what do you think is different? So I'll go ahead and put the air resistance in. Yeah, force. So the dog is pushing harder and the ground is pushing harder back. Does that make sense? On dog by air, and then we'll just say this one is more, right? And not necessarily in a crazy direction there. Yeah, so we'll say force push on dog by ground traction, okay? Yep?
Yeah.
Okay, so that's good news. Now we need to do the graph, yeah? Okay, so what do you think? I think I might just do 2, 4, 6, 8, 10, 12, 14. Anybody label this? 16, 18, okay? And then maybe I'll just say 5 and 10. How's that? Okay, so what happens first? There's an initial speed, so what's that on my graph? Right, and so what is that? That is the y-intercept? Right, y-intercept, okay, and so how long do I do that? For 8 seconds, right? So, right here. Yeah, okay. Then what happens? So it goes to 10 in how many seconds? Right, so from 8, what is 5? If I add 5 to 8, what is that? 13? So, and I'm going to 10 and 13, so I'm just gonna like find 13, which is like there, yeah? Okay, so then I'm just gonna, does that look like a good thing to do? Alright, how's that? Okay? Okay, so this is, okay, so let's annotate this graph. So what we know is that we need slope and area under to annotate, right? So the slope here equals what?
0.
Right, 0 meters per second. I think my colors are hard to see. What if I do that? That looks like it's easier to see, doesn't it? Maybe just on the overhead thingy. Okay, so slope is 0. What about the area under for this? What's it gonna be? Length times width? Yeah, so what's that gonna be?
40.
So x, right? So slope is, I just wanna add, slope here is what quantity?
Velocity.
What is the slope of
Acceleration.
a v versus t?
Acceleration.
So slope is acceleration. So we don't have any acceleration here, right? And area under is what? Of a v versus t, displacement, right? Right, and so what does the area under equal? Can you tell me?
40.
40, right? 8 times 5, so it's 40 meters. Great. So we know we need to do the same thing. When we annotate the graph, we need to do the same thing. I have sort of forgotten to put a title up here, right? So now I need to do that same thing here, yeah? Do it at your table, go. I'm gonna do mine, you do yours.
Yes.
So this one for that is 37.5 meters.
So I'd like to know the displacement. I'd like to know the acceleration and the displacement.
Oh my god.
That was such a good call. Logan's on this. He really wants me to have the pins. Hey, how about that rubber band? That's what I'm talking about. Okay, all right. So what's the acceleration? Gotta find the slope. Rise over run. What is it? If you've answered 1,000 things, we need to hear something from somebody else. What's the slope? 2. So we've gone from 8 to 13, yeah, in 5 seconds. 8 to 13 in 5 seconds. Do we really believe this is 2? I don't think it's 2.
It's 1.
I think it's 1. I think it's 1. Alright, if you got 2, you need to get your bearings.
It looks like it's 2, but since it's counting them in different increments, that's why it'd be 1.
Right,
Because
so
the
say more
seconds are by
words.
2.
Huh?
Because the seconds are counted in
Twos.
not one, so it looks like 2, but it's really one.
Right, so it's what? So you just have to look at the numbers, right? So if you go from 8 to 13, and you go from what, 5 to 10?
It's 5 over 5.
Yeah, it's 1. It's 5 over 5. Are we all okay on that?
Yeah.
Okay, so there's my slope. What's the displacement?
37.5 meters.
I agree. Does everybody else agree?
Yep.
X equals 37.5 meters. So if I ask you to annotate a graph, I mean everything here, okay? I mean numbers, label, unit, title, acceleration is like label, slope, and area under, okay? All right, so far so good? Okay, so that's what, A, B, C. Let's go to D. So D is, what does it want us to do? What was the dog's acceleration during the second part of the motion? Okay, so we found it with the graph, but let's find it. Let's do our givens, okay? So what's given? I would like to think G, U, E, S, S, and what that is given, right? Unknown, you don't have to write this every time, I'm just reminding you because it's kind of new. Equation, substitute, and solve, all right? So I just want to put the given out there. What have I got? Mass is what?
20 kilograms.
20 kilograms. What else? V naught is 5 meters per second for 8 seconds, constant velocity model, and V final is what? 10 meters per second after 5 seconds, and that's the constant acceleration model. Okay, so I know all that. What do they want me to find, at least in part, let's see, DI, what do they want? Acceleration. Okay, so A equals question mark. What equation would you like to use for that? We have these up here. What do you like?
V naught plus A times T.
Okay, so this guy says V equals V naught plus AT, and I want A, so I'm gonna have V minus V naught over T equals A, and what's that gonna give me for A? Let's see, 10 meters per second minus 5 meters per second over 5 seconds, that's gonna give me 1 meters per second squared for A. Yep? That okay? All right, so next it wants me to find out how long is the driveway, and this one's a little trickier, right? So how long is the driveway? That's gonna have a part 1, so I'll just say DII is gonna be part 1, right? So I'm gonna travel, I told y'all I love whiteout tape. Yeah, I love whiteout tape. Okay, so I'm gonna try this one. So part 1 is gonna be constant velocity or constant acceleration? Constant velocity. So what's the equation for constant velocity? What do we know? X equals what? Dune buggy model. VT plus X naught. And as long as it hasn't gone anywhere before the problem starts, X naught will be 0, right? Okay, so what can I do to find the distance traveled when it's traveling at a constant velocity? What can I say? What can I say?
Velocity 0 meters.
What's the velocity when I start? 5 meters per second for how long? For 8 seconds, and so that gives me how far at a constant velocity? 40 meters. You see that? All right, so how far did I go while I was accelerating? Right, so part 2, right? So part 1 is from 0 to 8 seconds, yeah? Part 2 is what? From 8 to 13 seconds. So what do you figure I should use for part 2? Find out how far. How far? Something with an X on the left. I'll show you your choices again. Louder and not the same people all the time. Let's hear from somebody new. How about somebody at the back table? Right there. Which one should I use?
I'm not sure.
Okay, so I want one with an X on the left and an A somewhere on the right.
The X equals X naught.
Yes, ma'am. X equals X naught plus V naught T plus 1/2 A T squared. All right, have I gone anywhere before it starts?
40 meters.
Huh?
40 meters.
Here's where I have, yeah, so totally, I can say, hey, no, here's what I think. I think I've started from 0, but this is the 40 meters, yeah? So I don't think it doesn't say, Fido is 20 meters away from the origin when he starts, okay? So X equals V naught, which is what? 5, right? Meters per second. Okay, and in this case, here's what I want you to see. I'm going to do this in pieces, right? I'm going to say, hey, I already did this. Now, do you see that here's the part sort of that I'm traveling with the constant velocity, and here's the part with the, right, so remember what we said. In this equation, am I out before it starts away from the origin? No. Do I have a velocity when the problem starts? Yes. So that's going to get me, so for 5 seconds, right, from 8 to 13, that's going to get me some displacement, right? And then what else is going to get me some displacement? 1/2, 1 meter per second squared, right, times what, 5 seconds? Squared. And where you're going to miss it is you're going to forget to square that, okay?
Didn't you have the constant velocity for 8 seconds?
We're not doing that. We're doing the velocity it has, right here. So this is about the velocity it has when it starts and about the acceleration, okay? And what we're going to do in the end to get the whole driveway is add them together, yeah? So we're going to add the 40. Hopefully we'll come up with this. Let's see what we got. X equals what? So 25 meters I'm getting due to my initial velocity. And how much am I getting due to this? I guess 25 times 1 and then half of that, yeah? So what's that? 12.5 meters. So what am I getting total? Oh, winner, winner, chicken dinner, 37.5. And now, if I want to know the whole displacement of the driveway, what do I have to do? Right, so X total, I should use this, X total should equal what? 40 meters plus 37.5 meters, which is 77.5 meters. X total. Okay, I feel like there's one more question. What was F? Huh?
So in a situation, could you just like, if you found the area under on the graph, could you just add that up? And then not
Sure,
put
but we're
all-
trying to show it 2 different ways, okay? So if you didn't have a graph and you just had the words, we're just trying to make the connection. Okay, so last question, last one, fast one, is D-I-Y-Y. Yeah? And so what is that asking me? F net? So what's F net? So I know F net, hold on. All right, so F net should equal MA, yeah? So what's that? Do I know M? 20 kilograms. Do I know A? 1 meter per second squared. So what? So what?
It's 20.
20 newtons. Bingo. Great, nicely done. When does the bell ring? 17 or something?
Yeah.
Okay, let's stop this thing. I feel like, okay.